Hello everyone and welcome to PyTorch Academy. Today we are going to build something really fun. We have thousands of wine reviews written by sommeliers summarized in this interesting data set in Kaggle. And we are going to use this description here, the short paragraph that simply explains how a wine tastes, smells and tastes. And from this text alone, we are going to teach a neural network to guess the grape. And the grape is here, a variety. Like we're going to guess whether it is Pinot Noir, is it Chardonnay, is it Merlot, or some other of our 10 or 12, as many as I have decided to put. So along this way, we're going to learn as well what is embedding, how to use a simple neural network, and how to train it and how to test it honestly. Okay, so first let's bring out the tools. We are using Jupyter Lab here, entering it, and we have NumPy, Pandas, Torch, and Matplotlib together with random. I'm just going to use here view and appearance, probably full screen. Okay, so next we are going to load the data here, and we are going to load it the standard way. It's going to be df, and it's going to be df for data frame, pd for pandas, and then read csv. I have prepared the file already. It's in my data folder, and it's called wine meg data 130k v2.csv, and we don't need the index column, so it's index column. Okay, shift and enter, and let's see what we have. We have a lot of data. Let me zoom in a bit, so probably better for you, I guess. And now the interesting part. This is the data frame. Yeah, pretty much we have the country, we have description, designation, points, price. The price is in euro or in US dollars. The province, region, taster name, Twitter handle, title, variety. This is what we're going to be guessing, and a winery. Okay. We're only going to be guessing based on the description, so anything else would be considered kind of useless. Yeah, let's have a quick look. For example, let's take a look. What kind of varieties do we have? So you can say df variety like this, and then value counts. And this is like the top varieties: Pinot Noir, Chardonnay, Cabernet Sauvignon, red blend, and Bordeaux style red blend. And we see that in our, length of 707 types, we have some types that are just Pinolo, just one. And it would be really tough to guess these ones based on our data. So we would be doing, yes, something else. Let's see, we are going to use the head, just the top 12. These are the varieties on which we are going to teach our neural network. Anything after Zinfandel would be cut out of the data. Yes. Makes sense, I would say. Yeah, let's take a look at the wines from Bulgaria, because why not? Bulgaria is a country that sometimes is famous with wines. So just to see what we got here. And we have a syntax error, of course. How about now? Let's see, we have it here. And if we want to get the whole description of something. Let's take a look and think. We can say, let's say, get the whole description of this rosé here under index 6970. We can say, what can we say? I have prepared something, so it's something like df.ilog, and something like this should be enough. This pale pink rosé is compromised, okay. And if we want to get the whole thing, it should be df description. Yeah, this pale pink rosé is comprised of 70% Pinot Noir and 30% Syrah. And I think I have this one prepared here. So this is the Veni 70%. Yep. And just to show you, like, this is exactly what we are talking about. It is here. This pale pink rosé is comprised of 70% Pinot Noir and 30% Syrah. Okay. Yeah, and the price on the side is still $9 and 6970. It is still $9 and the points are 86 and the points are 86. Yeah. Let's go back to full screen. Yeah, good enough actually. Now let's start keeping the top 12 most common grapes. How are we going to do it? We're going to say, hey, we are going to remove a lot of duplicates, and we are going just to take the first 12. And we're also going to remove a lot of columns that we don't need, or not actually. The columns, they can stay. Just removing the rows. Yeah, so the new df, we're going to use drop duplicates in description, and we're gonna say drop NA in the subset variety. So if they have and not available here, we don't want them. And also because we don't have like a result and we don't have anything in description, then we want to remove them. Ready. Let's see how many of DFs did we drop. We were having 129,000 here. Now we are going to have 954. Okay, we removed like 30 something. Now we just need the top 12, and it's gonna be the top 12 varieties. We're going only to teach our neural network on the 12 varieties, so it's going to be df variety dot value counts head 12 index top 12. These are the top 12 varieties: Pinot Noir, Chardonnay, Cabernet Sauvignon, Red Blanc, Nebbiolo, and Zinfandel. This is the last one. And we're gonna make another data frame, just overwriting. The previous one. Isin is a great option to say, then top 12. And then of course reset index and drop equals 2. Okay, and df shape, let's see, what do we got? Okay, 71,000 out of 129,000. Okay, we still have a lot of data, but with this one we can work with. Now is the part on which we're going to turn each review into a vector embedding, and vector embedding is something on which I would like to stop a bit more. So pretty much this is the whole idea about the whole video. The idea is that a computer cannot do math on the word, simply it needs numbers. So we turn each review into a list of numbers, and this list is called, in our case, a vector. So yeah, this list of numbers, it captures the meaning of the words. And the important property of this vector is the following. If two reviews, that means similar things, get vector that are close together, and two very different reviews get vectors that are falling far away apart. Unfortunately, we're going to use a vector with 384 dimensions, which is quite tough for a human brain to understand, but it works. We are going to use a model that is called Omni-LM, which has already learned how to do the embedding from millions of sentences. And from here on, everyone is just 384 numbers. And these 384 numbers are between -1 and 1. So it is a slow process, but for you it's going to be like a bit faster. So let's start the embedding process from sentence transformers import. Let me see. Nope, sentence transformer. Shift and enter. Well, it's a question about whether it would work. I guess it should be working, and then let's create the embedder. It's gonna be sentence transformer. The model is called Omni-LM L6 version 2. And now the big X would be the encoder with the embedder dot encode. We're going to encode the description, and we're going to encode it to list with a batch size 64, which is a standard one. Show progress bar. I'll say true. And normalize embedding. Also true. Normalize embedding is just to put it between -1 and 1. And it's gonna be as type 432, like this. And now we wait a bit. Yeah, just a grammar mistake here. If you take a look, this model does not accept any additional keywords. You see, like here, I missed the E, so I'm going to try it once again with the correct embeddings. Now it's going to go between 3 and 1112. And here, the interesting part is once it loads, I'm going to show you how these embeddings and all these vectors look. So after a minute or 2 or 5 or whatever, it is loaded and we have the big X with all the vectors in the 384 dimension. So how do these vectors look like? The answer is they look like this. These are all the vectors, and this is our first one. These are 384 numbers. So question to anyone looking, do you know what this is? This is called E notation, And it pretty much means that we have here this number multiplied by 10 to the power minus 2. So the real result should be 0.02 something. And the good thing is that we can see it. And it would be something like this. See, exactly like this, 0.0208. Yeah. If we want to see, let's say, something more interesting like this one, we should be having like 3 zeros or 2 after the dot. Should be like 0, 1, 2, 3, 4. Let's take a look how it looks. Yeah, 0.0022. And this is the 22. So this is what E minus 0.3 means. It means this, like this number, 2.23, multiplied by 10 to the power of, in our case, minus 3. Okay, so far so good. Let's continue. What are we continuing with? We will be continuing with this next part, and it's splitting the data into train and test. So before starting it, let's talk a bit. We have to point out 2 interesting parts here. First, the grapes are words, but the networks, they work with numbers. So we map each grape name to a number from 0 to 11. These are our 12 grape types. And second, and this is important, we split the data into a training part and a test part, and it's going to be 80 to 20%. And the model learns only from the training part. The test part is hidden, and it's going to be stratified. What stratify means that if we have, like, in our general data, let's say 60% Pinot Noir, we would be having 60% of Pinot Noir in the training data as well. Yes. So train and test, we're going to do it right now. The test is going to be our exam, and let's start doing it. So from sklearn, preprocessing, import label encoder. And the next thing is going to be from the model selection, import train test split. These are the standard functions that we're going to use. So label encoder, it's going to return label encoder like this. Let's see how it looks. Yeah, standard way. Our Y is going to be label encoder fit transform. We're going to give it the variety. And of course, S type. In 64, it's from 0 to 1. Nothing else. And what exactly did I do as a mistake? One required positional argument. Yeah, happens. Where fit transform df variety is written correctly. Dot s type. Oh yeah, I know what's the problem, of course. Like this. Yeah. And now we have even stuff. And our Y should be like this. Pretty much the first one is the 7th type of wine that we have here. And yeah, this is what the Y is. The Y is just a general vector saying this is what you are going to learn. This is the thing that you should be learning. And classes, let's see here, what do we have? Yeah, number of classes 12, of course. Then we built the index IDX, and we're going to use NP. Length of the data frame, and if we check it, yeah, pretty much just the index. And now index train and test. And train test split is one of those functions that returns two things. The first one is going to be in the train, the second one is going to be recorded in the test. So we give index, we give test size, 20%, random state, nope, and stratify should be yes. Everything's ready, and now we pass xtrain and xtest. It's going to be equal to x index train and x index test. So this is how we got it, and this is how we have it. Okay, so y train and y test. It's going to be pretty much the same, but just with y. Index train, y index test. So just to explain once more, this is the train, this is the test, and this is what we are learning from here and what we're learning from here. For example, xtrain 12 would be giving us this, and this is the embedded vector of the 13th text that we are giving. And for this xtrain, we have to find a way to teach our neural network that this should be 6. And the 6th one is actually a type of wine. In our case, the 7, because it is an index, so it's probably somewhere here, the Syrah. 1, 2, 3, 4, 5, 6, 7. Okay, Sauvignon Blanc, doesn't matter. It matters, but not in the example. Okay, so now let's build a simple neural network. And the simple neural network, we are going to build it real easy. We are going to use, of course, standard functions, standard formulas, standard modules. And the simplest way to think about the neural network is pretty much a function with adjustable knobs, which we are going to call weights. Numbers go in, numbers come out, and training is the process of turning those knobs until the output is good. Our training would be a tiny one. The first layer takes the 384 numbers I'm talking all about, because these are our dimensions, is with 384, and it mixes them in a way to generate 128 new numbers. Then we use ReLU. ReLU is a function that pretty much does this. If we have, it looks like this. Here is the 0. So if we have like a number, and here is like the x-axis, and this is the y-axis, and this is the x-axis. So, okay, ReLU is actually like this. And then, yeah. So x and y. It's pretty much the simplest function possible that you can think of, at least I can think of. Like if it is a positive number, it returns the number. If it is a negative number, it gives a 0. So it's a maximum of the 0 and the number. And it's really simple, but it works. So as I said, keep the positive values, set the negative values to 0. That little non-linearity is actually what lets the network learn complex patterns instead of only the straight ones. Then dropout, which during training randomly ignores some of the numbers, so the network does not lean too hard on any feature. And finally, a layer from 128 down to 12, which gives us 12 scores, 1 score for each grape. And let's build it. It's going to be interesting. At least I hope so. So it's going to be a class, and the class is going to be called GrapeNet, and we're going to use NN module. What was NN? You can see here, torch.nn. This is what we want. Defining the first dunder for the init. It's going to be self in dimension and number of classes. Inheriting the super. That's the class below. So self.net equals nn.sequential. Let's see. Okay, it works this way. And here we write nn.linear in dim 128. This is what I mentioned already. We're going to use the relu, this one, and the dropout 0.3, and at the end the linear with 128, and it would be returning the number of classes. And the forward function should be only self and x, and it would be returning self.net. Let's see whether it works. Yeah, it works. So model was GrapeNet, x shape 1, and n classes. If you have forgotten what this is, let me remind you. 384 is the number of our vector. So each vector is with 384 dimensions, and n classes is 12 from 0 to 11. And let's see, what do we have when we write model? We see something interesting. We see sequential, linear. That's the first one. Then we have relu, then dropout, in place false, and linear again. What are all these things? I have prepared to answer this question if you have it. So GrapeNet here is our model. Printing what it has inside. Net sequential means that the layers are stacked in order and the data flows through them top to bottom. Sorry. Yeah, linear in 384, out 128. This is what we got from here. Is the first layer. Linear means they are fully connected. Each of the 128 outputs is a weighted sum of all the 384 inputs. Just explaining quickly what is this. We have 384 of this, like this, 384, and then we have 128 of this, 128, and each of these is fully connected like that. Ta-da! And then to the next one, and then to the next one. we are updating a lot of weights. Yeah. Okay. So what else? Bias true here means that each output also has its own adjustable offset added to it. So one additional number that our model has to calculate. Relu, yeah, that's the function that I explained already. It gives a maximum of 0 or the number if it is positive. So yeah, if it is a negative, it just returns 0. Dropout P03 in place false. What is this? So it randomly drops 30% of the values during the training. In place false is just a technical detail. It works on a copy instead of everything, instead of overwriting. Yeah, it drops the 30% of the values during the training just so it doesn't learn wrongly and learn everything by heart and makes some kind of overfitting. On the contrary, it's good. Dropping 30% is quite okay. The next layer, pretty much giving 128 from here and outing 12 here, is pretty much the output layer. Yeah, this is how it looks. And now it is time to train it. And for this one, I'll just write the code and then I'm going to talk about it. Okay, so this is where the network learns. We have a loop here, and the idea of this training loop and the whole code is actually simple. We show the network a small batch of wines and it makes a guess. We measure how wrong the guess is with a loss function here. It's called cross entropy, and it's the standard loss for classification. And then we have an optimizer here. Looks like it is out of the loop, but it is inside the loop here. Optimizer, it's in the loop. Criterion, it's in the loop. Yeah. And then the optimizer nudges all the knobs a tiny bit in the direction that makes the loss smaller. We repeat this process over and over. One full pass through all the training data is called an epoch. Epocha, depends where you're coming from. And we're going to have like 20 of them. And inside of each epoch, we add up the loss from every batch and print the average at the end. So you can see one clean number per epoch that falls down smoothly. I'll simply say every second epoch. We're going to, okay, yeah, we're going to put so only the even numbers. Yep. This is what actually learnings should look like. The loop is kept deliberately simple, so with a fixed number of epochs, nothing fancy, and it should be easy. Let's see. So the first loss is huge, and then it goes smaller and smaller. That's good. It's really good. And after some 20 epochs, our loss would be, yeah, here. It's okay. Now let's discuss how accurate the whole thing is. So it's time to grade it. For each test of wine, the network actually gives like 12 scores, saying, is it wine number 1? And then it says, I'm guessing it's 5% this wine. Is it wine number 2? It's 2% this wine, yeah. And what we do is we take the grape with the highest score as its guess, and this is what argmax does. Yes. So for context, like randomly guessing of 12 grapes, we would be around 8%. Yeah, like 100 divided by 12 is around 8 point something, 8.3, I guess. We have, yeah, good for me in math. But we're going to try to hope that we are but a bit better. So evaluating, and let's see what we're going to have. Okay, first I double clicked here. I'm going to have it as well here. And okay. So the test accuracy is 0.734. And this is just an example. We pretty much took the first 3 in our data. And we have the true value and the predicted value. The predicted value is Pinot Noir and the true is correct. Then we have red blend and Riesling, and we also get Riesling. So we are actually quite okay. Here on the next one, we are going to compare what we get with all our neural network versus simple model called logistic regression. I have a few videos about it. We can do logistic regression on this one. So ours is having a better accuracy than logistic regression, so we can say it is worth it. Yeah. Yeah. I mean, we defeat the logistic regression with some 0.73 versus 0.70, which is better actually. And now let's see something like how our wines look like. It's called PCA, this method, and pretty much what does it mean? We are having a decomposition. We are kind of making 384 dimensions into 2 dimensions while keeping as much of the data structure as we can. So, and the idea of the 2 dimensions is so we can have a picture like this. Yeah, so this idea pretty much here shows us that if we take the 384 dimensions and we make it into 2 with PCA, called component analysis, and the P was principal component analysis, yes. So, I mean, we're doing PCA here, and somehow we try to show that from our 384 dimensions, we have 2, and Pinot Noir and Chardonnay are somehow distinguishable. I'm not saying they are completely distinguishable. I'm using somehow this word. Yes. So somehow Pinot Noir goes a bit up and Chardonnay goes a bit down. And in the end, let's see what we can do. Is this function that I have built, predict grape. Pretty much what we can do with predict grape is we can say, hey, I'm going to write you something and you have to predict which grape it is. And predict grape is going to be using something like great, tasty, sparkling wine with a lot of fruit taste, something like this. And it says it's Zinfandel with 28.3%. And our model is going to return Zinfandel, but let's see if we get all of them, what is going to happen. Yeah, okay. It's saying it's not a chance for the Nebbiolo, and the others are somewhere here. Of course, it only knows these 12 models. So let's see if we write here cheap wine, what is it going to predict? It's going to predict Pinot Noir. What if it is expensive? Also Pinot Noir, but with higher possibility. Well, this is, what if we say I drive to Mexico, for example? Okay, Chardonnay with 66%. Yeah, that's the interesting part. Like, it always predicts something. Okay, test wine ever for a blogger. Yeah, Chardonnay. Obviously, this is the model that we have built. In a way, this is the model. The rule is garbage in, garbage out, good things in, sometimes good things out. But generally, this is the whole thing. We turned text into vectors with our model. These are the vectors, and this is the text, for example, where I was having a lot of stuff. Yeah, this pink rosé is comprised with 70% Pinot Noir and 30% Syrah. Yeah. So we turned text into vector with an embedding, trained a small neural network to classify the grape, checked it honestly on a test set, compared it to a simple baseline, and even visualized a bit the data. So the exact same recipe, text to vectors to a small model, works for tons of other problems. Yeah, reviews, support tickets, news articles, anything with a label. Yeah, try it on a dataset you like. And thank you for watching. Okay, here we guessed rosé. I hope you enjoyed this part of Vidosh Academy. Like and subscribe, comment below if you have any questions, and take care of yourself. Goodbye.